Thanks for your patience. Now over to you, Yash. The virtual stage is all yours.
All right, thank you. So I see a lot of folks joining across the globe as well. Thank you for joining. And I think majority are like having, I mean, 0 to 3 years of experience working on the data science or data engineering domain. So I suppose let's touch base on some basics as well, right? It would be very helpful for you. I see there are quite experienced folks as well. Thanks for joining, actually. And we'll be talking about Dataflow, Apache Beam, and how Dataflow helps you to scale your ETL pipelines, right? Without having to learn different technologies for batch and streaming data both, right? So without further ado, let me share my screen. One second, I'm finding something. All right, is my screen visible?
Yes, your screen is visible.
All right, thank you. So, uh, Apache Beam, right? I mean, we might have heard about people who have experience, might have heard about Apache Beam. It's been here since probably 7 to 8 years now. And it's been since very long back within Google Cloud, also called as Dataflow SDK. We'll talk about the history as well. But data flow, right? When you talk about data flow in general, not about the service, one thing comes to our mind is data pipelines and why data pipelines are required. Enterprises and organizations are now moving towards cloud, and more so ever, they are moving towards a more data driven organization, right? So they require ETL pipelines, which we often call it as data pipelines, to transform the data into a more usable fashion so that they can get insights out of them, right? So when I said ETL pipeline, what is this ETL, right? Ultimately, like what is that for the freshers, let's say? I mean, ETL is an abbreviation for extract, transform, and load, uh, and it's a general pattern, right? When you talk about a pipeline, there is a source and there is a destination, and there is something that happens in between, right? So when you extract data from somewhere, let's say you are copying from Google search, you are extracting it, you are pasting it into, let's say, an Excel, you are kind of putting it somewhere so you can work on it. You apply some functions on Excel, you are doing some transformations, right? And finally, when you store that file, it's like you're loading that file, you finally extracted that data from the web to your local machine. This is a very layman example, but that is how the ETL works, right, in real life as well, for the, I mean, in a very layman fashion. So, but how organizations use ETL these days is they want to make sure that they generate insightful data, and data that can speak for itself, right? The data speaks. And when we talk about big data these days, bad data also comes into the picture. Dirty data also comes into the picture. And when you try to generate insights from this data, right, it's a problem. I mean, it will give you incorrect results. Your insights might go wrong. There would be outliers, and it would give you false information ultimately, which we don't want, right? So, hence, this pipelining concept came in, which can channelize your data in such a way that it could be loaded into different fashion, into different structures, ultimately to destination systems where you want to, let's say, visualize your data, or maybe do more transformations, run some machine learning models after curating your data, and so on and so forth, right? So, I mean, professionally here at Google, like how we define ETL is, I mean, it describes, like I'm quoting it, ETL describes the end-to-end process by which a company takes its full breadth of data, structured and unstructured, and managed by any number of teams from anywhere in the world. So it's going to be very messy. Hence, you require a data pipeline. And it gets it to a state where it's actually useful for business purposes, of course, right? These days, we are seeing a lot of machine learning models coming in, and the machine learning models are trained by some data. It cannot be trained by data which is readily available. You need to do something about it, right? And also, because the organizations are now moving towards a more data driven way, they must also cope with the accelerating volume and speed of data. Like we see these days, everything is digitized, right? So everything is having some data output. So we want to make sure that even the pipelines, right, the pipelines are able to handle that big amount of data, the velocity of the data, the variety of the data, the veracity of the data. We want to make sure that this data is handled by our pipelines seamlessly. And this data, right, can vary. Like for example, an e-commerce website, you could have a sale on an e-commerce website, and the traffic may shoot like suddenly, and like during the night it may go down to maybe tens of thousands at least. So in that case, you want to make sure that your pipeline works with very less data, and also with data that is manageable, probably 10x of what you're expecting. So that's what the data pipelines are, and this is how we are kind of having the ETL pipelines built these days to ensure that they are future proof. Talking about ETL pipelines, what is Apache Beam, right? Why Apache Beam? We have heard about a lot of Apache. I mean, a lot of frameworks we are seeing for data. We have Apache Spark. We have the whole Hadoop ecosystem. Then why Apache Beam? What is this Apache Beam, right? And long story short, like it's a library to write your pipelines, and it's I mean it works in a different way. How your data is kind of processed within your pipeline. Writing a data pipeline using Apache Beam is quite simple. Behind the scenes, there's a lot of things that happens, and all of the heavy lifting is handled by what we call as a runner in Dataflow, or maybe in Beam, right? In Beam, we call runners which run your Beam code. Apache Beam supports both streaming and batch pipelines, right? Let's say you are running a batch data pipeline job. Basically, it extracts data from source systems and puts into destination systems. Okay. Let's say it does it every hour. Every hour, it kind of dumps data from one system to another for some reason. Let's say I want more recent insights. I want more latest data in my dashboards, probably, which I'm seeing live every day, every hour of my day. What should I do now? I might want to migrate from a batch pipeline. When we say batch, it kind of batches data. Like it captures data for every hour in our case and puts into the destination system. We don't want to do that. We want to capture real-time data, so we want a streaming pipeline, and that requires you to kind of have a learning curve, modify your code, probably change your whole code, have a new kind of a stack which handles the streaming data, which we see that there are services which help you handle the streaming data already. Then why Apache Beam is here? Apache Beam is to make sure that you get a unified way of developing this pipeline. So you get almost minimal change when you want to move from batch to streaming. It also is very easy to code in Apache Beam because it kind of focuses more on the business logic which you write as a programmer or a data engineer, and offloads a lot of heavy lifting that you might want to do to scale your pipeline, right? When I say scalability of the pipeline is when let's say there is a pipe I mean, let's say that there are terabytes of data that you want to process, right? If I do it in a normal fashion, it takes probably days and years, which I don't want. So what I'll do is I'll offload it into a multiple workers. which I call it as a cluster, which will have workers, and each worker will be responsible for a particular set of job, and we'll kind of separate out the responsibilities and finally aggregate it to give you a final output. So that will kind of offload and parallelize. Let's say job takes 24 hours to do something. I'll have 24 instances doing a job and it will complete in 1 hour, right? So that's how the scalability works. And that's same for a lot of frameworks which are available for data processing these days. But Apache Beam, make sure that you don't, as a programmer, as a data engineer, I want to focus, as a data scientist, I want to focus on, the business logic of the things. I want to make sure that I kind of deal with the data. I don't want to deal with scalability issues. I don't want to deal with anything else. I just want to make sure that I write a code which is fault tolerant, and that's it. Just want to make sure that my code works. And for scalability, I want to make sure that my runners, which I'm talking about, which are responsible to run this Apache Beam code, will handle my scale. And Apache Beam supports Java, Python, Go, and Scala as well. And there are a lot of runners available right now in the market. You have Apache Flink, you have Spark, you have Samza, you have Cloud Dataflow, which we are going to talk about in some time, and why Cloud Dataflow is actually better than all of these. Uh, One fun fact, Google donated Dataflow SDK to Apache in 2016, and that's when Apache Beam was born. So ultimately, the understanding of Apache Beam ecosystem and the integration of the Dataflow SDK, which is now called Apache Beam, along with Cloud Dataflow, which is a service, which is a runner, it's quite seamless, and it has a lot of things which might drive you to use Cloud Dataflow as a runner. So this is how the Beam works, right? You source your data from a diverse set of sources. Beam can connect to any data source. You can create your custom data sources as well to connect to it. And it can process like a normal Python code, and you can directly write it to n number of destinations. It could be a database, it could be a file, a system, and so on. Uh, when you talk about syntax and compatibility, it's quite similar syntax across the SDKs. You have Java, you have Go, you have Python, you have SQL, and so on and so forth, right? So if you see, like in Java, we are using a function called apply function. Python has the same function overloaded using the pipe operator, and automatically the apply function happens. We'll talk about the code in some time, but previously, mostly Beam supported Java SDK, and most of the code right now, if you see, is available in Java SDK. Things are changing, but there is something called portability framework, which we introduced, and it helps you to have a uniformity across the SDKs and make sure that, across the SDK, across the runners, things can work with each other in tandem. So, and basically the portability framework, right? It ensures that the new Beam SDKs which might come, can run with most of the existing runners and any new runner which might come in future. It's as simple as that. Uh, Going to the next slide, there are certain core concepts which we need to know about Apache Beam before we move forward and talk about Dataflow, right? Since Dataflow uses Apache Beam, Apache Beam has some concepts. One of them is the pipeline object. When I talk about pipeline object, now we'll move more towards the programming aspects of the things. So the pipeline object is something that encapsulates the whole pipeline, right? Your pipeline consists of data and transformations, right? And the whole thing is wrapped under a single pipeline. And it includes reading data from some source system, transforming it, and writing it somewhere as well. The whole thing is encapsulated here. And you can also specify like any custom options which you want to fine tune your data pipeline, right? Your data flow pipeline, the Beam pipeline. You can learn more about it. Because of the time, I think we'll move forward with like the other core concepts which we want to talk about, which is P collection. P collection is a very important concept in data flow. P collections are nothing but an object that holds your data. across the pipeline, right? It's a distributed data set across your nodes. So when we talk about nodes, your runner will have a cluster, and cluster will have a set of nodes. Data will be distributed across these nodes, and I mean, it is specific to a pipeline object, right? For a particular pipeline, this p collection exists. It cannot exist for a different pipeline object. One pipeline, one multiple p collections is the concept. And I mean, the elements cannot be processed individually within a P collection. You can assume P collection as a table, right? A table has multiple rows, and every row cannot be processed individually. Dataflow handles all the records in bulk and kind of try to process it together so that it can scale out. When we talk about P collections, you will say, hey, this is a table. What about streaming data? What about batch data? A batch data makes sense when you have a table and data preloaded in that table. For streaming data, we have something called as unbounded collections, where there is no bound to your data, your P collection. Your data can arrive, and based on a window function, right? Like data keeps on coming in. Let's say I define a window of like 5 minutes or 10 minutes, right? So the data from the past 5-10 minutes keeps on coming in, and I will kind of have a P collection which holds that data for a certain amount of time with until I process it and move it forward. And this is all about P collection, right? It kind of holds your data within the pipeline. Then we have P transforms. So P transforms, I mean, you can talk about, I mean, you can say P transforms are everything else in the pipeline apart from holding the data. P transforms are everything that helps you to read the data from a data source, transform it, and also put your data into the destination, offload the data into, let's say, a database or a flat file system, and so on, right? So P transform also includes a lot of, I mean, operations that you can do, a lot of transformations that you can do. I mean, along with, like within your pipeline, and there are a lot of inbuilt P transforms which are available by Dataflow, which we'll talk about now. I mean, when you want to just take a complete picture of it, you can say a pipeline applies P transforms to each new output P collections until the processing is complete, right? So when you read data, it's a new P collection. You transform that data, the output is a new P collection. You do more transformations, the subsequent output goes into that new transform, and finally the final P collection gets returned to your destination via a final P transform, which is, let's say, writing to a BigQuery table or writing to a cloud storage and so on. Pipeline and P collection, I mean, if you want to see just a random Python example, it's as simple as importing the Beam package in Python and creating the pipeline object, and finally piping it to create a new P collection, right? Here we are defining a P collection manually. And you can also use the Python object to read from a text file from cloud storage, right? So you can read from this cloud storage and create this lines P collection. So here lines is a P collection which gets created using this Python object. Going towards the P transforms that I was talking about, and a lot of important P transforms which we'll touch base on. One of the P transforms is Pardue. I mean, it's similar to the map phase. I mean, I would say if you are coming from a map reduce system, it's similar to the map phase of the map shuffle reduce algorithm, where I mean it considers each element like and tries to do some processing for each record of the P collection. And I mean, the P transform, right? The Pardue can emit either one record for every element in the P collection, or it could emit more than one. Uh, or it could be, an aggregation of everything. You will need to provide the code within this Pardue. I mean, we'll see about an example how this works. I mean, it has to be within a doFn object. Like, why do we need this doFn and all of this, right? Pardue and doFn. I mean, this is how the Apache Beam is developed, which helps you to kind of abstract the scalability of the things and your user code. I mean, the code which you have which you have written. So it helps you to do that, and that's the reason you might want to import these do-fn and pardo and all of that, and ensure that you kind of follow these some rules which help you to have a more distributed processing, right? So a do-fn object, right? What is a do-fn object? It helps you to kind of parallelize the operation which you define within your function. Let's say I have a function which kind of counts the number of words within a paragraph. Then I will have a function which will help me count it in a distributed fashion. So that would be a do-fn for me. I mean, do-fn object is what you pass to a pardo. We are talking about a pardo here. So I mean, do-fn is something you pass to a pardo, and ultimately the do-fn contains the processing logic, and it gets applied to all the elements. If you are coming from a map reduce environment, I mean, you might be knowing what is map and flat map, but to make things short, so map basically it helps you to generate like one output per record. So let's say I am kind of transforming like one record within my P collection. I mean, I'll have like one output for that record. Similarly, for flat map, it can be one, or it could be many, or it could be less as well. Coming to the next one, group by key and co-group by key, right? I mean, it's similar to the shuffle phase, basically. It's used to aggregate the data, as the name says. I mean, it groups your data. I mean, it applies a reduction operation to kind of group your data. So hence, group by key kind of, I mean, reduces the size of your P collection, right? I mean, it represents the transfer from a multi-map, right, to a unimap. Basically, when I say multi-map to unimap, so as I said, your P collection has multiple keys and individual values. Unimap is unique keys to individual values, basically grouping your data by some grouping clause by a key. We have something called as a co-group by key as well. Co-group by key performs a join like for of more than 2 3 P collections, like what you wanted, like whatever you want to do by joining the P collections, and it accepts a dictionary basically and kind of groups by all of that data using a common key uh, uh, across those P collections which you're trying to combine. And I mean, it creates a single output P collection, as I said. I mean, the example which I was talking about. So let's say you are having like a P collection of let's say 4 words. Hello, hello, it's me, and you wanna count like what is the length of each word using flatmap or map. You can do that directly by calling beam.flatmap or beam.map, and I mean you can directly use a lambda, a Python lambda, to process each element within your P collection and directly call the length Python function, which calculates the length of the words within your list. Uh, Similarly, I mean, now talking about do fns, right? Flat map and map also helps you to kind of call a do fn, but you can also have a custom do fn, right? Apart from the inbuilt Python functions like length, you can have a custom function like compute word length, which will help me find out what is the length of the word. And what I'm doing here is I'll be basically calling it using the beam.pardo function. Sorry, we're calling it using the beam.pardo function, and using the group by key, I will be kind of joining all the records in this one and counting like how many cats and dogs are there. So these are like quick examples like what you could do using these transform functions. And coming to the other core transform functions, we have combine, flatten, and partition. So combine, I mean, helps you to combine the collections in your data. Basically, I mean, it helps you to collate the data. It's kind of group by, but you are not grouping by the elements, but you are kind of combining like data to get some aggregate output. I mean, it gives you like an inbuilt functionality for summing, getting the minimum and maximum data from your p collection. And in general, like combine consists of four phases, right? You can write your own combine fn as well, which helps you to kind of get a combining operation of the p collection for whatever things that you want to do. So let's say, I mean, the four operations are like create accumulator, where you will initialize anything that you want to initialize. Let's say I want to initialize a variable to, from a zero. I will add input. Let's say every time I come across a word, I will add one. So it will be 0, 1, 2, and so on. I will merge it. So let's say it's a paragraph. So I will distribute it across like all the nodes and everything. One node gives me 4, another node gives me 3, another node gives me 3. So 4 plus 3 plus 3 gives me 10, which will be my extract output. So these are like very important steps within a combine FN transformation. Then you have flatten. Flatten, it merges your multiple p collections into a single p collection, provided your p collection has a common schema. Of course, it's like a union operation, you can say. Similarly, partition, it can store data with the same type, and it splits a single p collection into a fixed number of smaller collections, and so on. I mean, it's kind of a reverse operation of what we are doing in flatten, but it helps you to create partitions of data based on a particular key or something, and create like smaller collections out of it. Like going to the examples which are more meaningful. Let's say I want to calculate like, a sum, a bounded sum, right? Like you can see this function, it kind of creates, calculates a sum of values, and checks the bound, right? Like whatever is the minimum, that is my bounded sum. So let's say I have let's say I have like a p collection having some set of values. Whenever I call beam.combine globally, what it'll do is it'll try to call the bounded sum function. It will calculate the sum and check whether it is minimum of the bound or the summation value. And accordingly, it will emit the value to the smaller value of the sums. And this is how, I mean, you can use combine for multiple cases. This is one of the example. You have I mean, you can also flatten your p collection by just having all the p collections all together and calling beam.flatten. That's it, provided all the three p collections have a similar schema, right? And finally, I mean, for partitions, right? Let's say I want to segregate my data across certain percentiles, and do something with it. What I'll do is, let's say in this example, what we are doing is we are having a function called partition fn, where it takes the student and the number of partitions which I want, and it returns an integer value out of it. What we are doing here is we are calling beam.partition and passing in all this, we are passing in the student data, and we are calling this partition, and we want to get 10 partitions out of it, right? So when we call the beam.partition with the arguments, this is the function name and this is the argument. So it only takes one argument, right? So by default, whenever you call a function from the Beam API, the first argument is the name of the function. The second argument is always the second argument of your function. You will think, okay, what is the first argument? The first argument is always the p collection itself, the p collection which is there in the pipeline. So when you call partition fn, my first argument is the p collection. The second argument onwards, you can specify everything with comma. So now let's say when I call this with, I want 10 partitions. What I'm doing is I'm calling a custom function which gets me percentile for a given student, and I'm calculating like what partition the student should go to, right? And finally, let's say I want to just get the 40th percentile or something. I can directly access it by this particular index 4 to get the 40th percentile of the student. I mean, what is the 40th of students, and so on. So this is how you can apply these transforms. There are I think more transforms. You can also create your own custom transforms by using dofn and pardo. And yeah, but when we talk about transforms, we also want to talk about connectors, right? We have connectors to source, and we have connectors to destination. And I mean, Beam provides you a lot of connectors already, so you need not worry. I mean, there are connectors available for most popular database systems as well. You can check out the Beam website, which will help you to know like from where the Beam can read and to where the Beam can write. We have an example for right, I mean, reading from BigQuery, reading from a text file, and writing to BigQuery. So these are inbuilt Beam IO transforms and connectors. Basically, it helps you to read all the CSV files from a particular path, let's say in GCS. And it for BigQuery, you need to specify a table spec, like what table and from what data set you want to read a data, right? And it kind of reads that data and puts it into a p collection called lines, and so on. Like if you want to write it to somewhere, you write it to text file. You can specify the suffix, you can specify the name of the file, I mean the folder where you want to save that file. And similarly for BigQuery, right, like what p collection you want to write to, and what schema that table should have. And you specify other BigQuery flags as well, like write disposition and create dispositions and all of that. So it helps you to kind of have more integrations with well-known databases as well. uh, we talked a lot about Beam, right? It gives you a good foundation of how Beam helps you to write a code, write your code, yeah, write your data pipeline. But what is Dataflow? I mean, as we talked about previously, it's a runner, right? Then what are the benefits of using a Dataflow, right? uh, it's a fully managed service for running your stream pipeline or your batch pipelines. And it automates the provisioning and all the management activities of the cluster, which you normally might have to do manually. I mean, sometimes in other places. And Dataflow ensures an exactly once processing, which is very helpful, which is actually needed. If you process a data more than once, you don't know what will happen, right? You'll get uncertain results. It supports a lot of data processing use cases like analytics, real-time AI, sensor and log data processing, and so on and so forth. Uh, Dataflow provides you ready-made templates to create a simple pipeline from well-known systems to write data to a well-known system and so on, right? So there are Google provided templates for them. You can create your own template as well. It's a custom template. You just need to code in a way so that you can create a template and provide custom parameters at runtime. So your code becomes dynamic. And that's an old method. The new method is a flex template in Dataflow, which is pretty new. It's a Docker based method where it kind of packages everything together, and it has a lot of benefits of running a data pipeline more faster than creating a custom template as well. What are the design considerations while you are designing your code for Dataflow, right? I mean, when you're designing in Beam and you're going to run it in Dataflow, some design considerations, actually it applies, most of them applies to Beam only. I mean, for reusability, you should go with Dataflow templates. They are the best. It helps you to templatize a code so that it can work with different types of inputs, go to different types of output. Uh, you can have custom parameters based on your business use cases. It gives you exactly once processing, so you should write code in such a way that your elements in a p collection can be processed at least once. And if they are processed, I mean, if a function is called more than once, I mean, it is possible that okay, it might have failed previously and Dataflow tried to retry everything, right? And hence there is no guarantee like how many times a function may be called, right? As I said, your p collections is distributed across the nodes, across the workers of a Dataflow cluster. Every cluster will have its own instance of your function, your transform function, and every instance will have its own group of elements from a P connection, and they will try to apply transform all together for this group. So you have no control over how that data is grouped, how you are up, how many instances you can create of that transform, and how many times your function will be invoked, right? So you need not worry about anything like for this. Dataflow handles it for you. Because it ensures exactly one's processing, and you can call, you have to write your code in such a way that it is idempotent as well. If your code is returned multiple times, it should produce same results, right? So there should not be any state sharing within your code. It has to be thread safe as well, because Dataflow is a highly parallel, highly distributed framework, and hence it has a lot of advantages, right, for distributed processing. And you also need to make sure that, if for whatever use case I'm using Dataflow, are there any support for IO connectors? If not, can I build one, right? Dataflow has a lot of advantages of using, because it is feature packed. It complements the Apache Beam framework which we developed, and the whole Apache Beam framework. The other features, these are really good features. There are more features. The top five, which are quite useful, is you can horizontally and vertically scale your data flow cluster. Vertical scaling is a new feature in Dataflow. You can dynamically adjust the cluster capacity based on the data that is coming in. It is quite useful in stream processing as well, if not batch. Let's say you have a predictable batch workload, it's fine. But if you have an unpredictable stream workload, horizontal and vertical order scaling works like a charm. You have data flow shuffle as well. People coming from a big data ecosystem, they might be knowing like what this shuffle is, right? If you have worked on Spark, you must have known like how do you handle shuffle operations. So when you try to group data, join data, right, a lot of shuffling happens across the nodes. Like data, they try to collate data into a single node and try to join it or try to group it and so on. So data flow shuffle ensures that you need not handle your code in such a way that, okay, I need to handle shuffling, and it might impact my pipeline performance. No, you do not need to tune your pipeline. Data flow shuffle will handle it for you. You have Dataflow SQL. Dataflow SQL is quite beneficial. If you are using BigQuery, you can directly write an SQL to read data and write data to a different table or somewhere else, and provide this SQL query to Dataflow so that it can launch a Dataflow pipeline for you automatically. So it's quite useful for easier use cases and patterns where you have data in BigQuery and so on. You can also do real-time CDC, right? Like for streaming pipelines, as I said, Dataflow provides the best interface, and the Beam supports it. And for real-time CDC, Dataflow helps you to kind of capture real-time change data. CDC is change data capture. So it has inbuilt connectors for Devizium as well, which helps you to capture changes from, let's say, one OLAP or one OLTP system and capture it somewhere else as well, for any processing or for redundancy in my infrastructure. And similar, we also have streaming engine. Now it separates compute from storage. It directly connects to the data flow backend, and it significantly improves the auto scaling and the performance and increases the data rate. It kind of improves the overall performance, kind of makes your streaming so fast. There is no latency. It's very low, and streaming engine helps you to do that. So you need not tune your cluster to handle a high velocity stream and so on. Finally, coming to the demo, and like we are kind of we talked about Beam, we talked about Dataflow, but how this Dataflow console looks like and how this code looks like, right? Let's go and see the console itself. All right. So I hope my browser screens are visible, and let's go to the the data flow console itself. Okay. So when you go to the data flow console, you will see that an option to create a job. Okay. So when we talked about data flow templates, like an inbuilt templates that Google provides you. So let's explore that. What's that? So you need to just provide like a name, like a test 123 or something. I'll have this region, data flow templates. So these are data flow templates which I was talking about. And you get like common patterns already implemented. Like for example, Cloud Spanner to change streams to BigQuery and so on for CDC, as I was talking about. You have data stream to BigQuery, Kafka to BigQuery, you have PubSub to BigQuery, and there are a lot of such templates that you see here for most of the very important sources and destinations. It also has support for JDBC. So if your database is JDBC compliant, it's best to use this template and directly dump your data into BigQuery, let's say, or you want to move it to PubSub and so on. So you have like these templates, and let's say I just want to get started. I want to see like at a very base level how these templates look like. So when I click on this one, a graph will be generated. Like this graph is nothing but a graph that Dataflow generates. It's a DAG basically for your job. Like it reads the lines, it counts the words, it maps the elements from all the workers, and kind of writes the count to a destination, let's say to a file or something. So because it's a template, it has a set of predefined parameters. So every template might have a different set of parameters. So this one has a parameter for, let's say I want to check for an input file, and for what output I want to check. And it requires a temporary location to stage your data as well. And finally, when you kind of run your job, it will show you like the job is successful or failed. I mean, it will have these statuses as you can see here, and it will also show you how many records it processed. So like it kind of read the lines from particular file, let's say. It kind of added 15 elements in this stage, and then it tried to map these 15 elements and write it to a destination file. Okay, what is the destination file? Where is the destination file I provided? It is nothing but the output file which I must have provided while configuring this job, right? So this was, about the data flow console. And when you just see the job metrics line, right, it kind of tried to scale. When you see the scalability, it kind of tried to scale from 0 to 1, and from 1 to it went to 2, right? So it kind of scale my data flow job to ensure it works fast. And finally, my output was returned to the destination, and the data flow job completed. So when a data flow job completes, it's a bad job. A streaming job keeps running. You have to stop it manually because just streaming data keeps on coming in, right? And when you talk about data flow, and you can also have your own work, your own notebooks. You can create a Vertex CI notebook, which is compatible with Apache Beam, and a user managed notebook, and it will have a set of examples as well to go through. So the pipe, let's say we'll go through a code for first of all, which kind of counts the number of words, right, within a particular file. So this is the code, and all you do here is you're importing you're basically importing like all the dependencies, and then finally creating this do-fn function, which is very similar to what we saw, right? It kind of extracts like words from that particular paragraph or the file, and it tries to count number of words. And finally, you will see this run function. This is what I wanted to talk about. So what is this run function? Run function is nothing but, the entry point of your data flow code. So run function gets triggered whenever you run your data flow, and you provide like certain arguments which are required for this data flow code to run. These are the arguments, which is the input file and the output as well. And finally, I will have some pipeline options for this one, right? And these are nothing but my default pipeline options, and all of these arguments which I want. There are pipeline options available which are quite advanced and help you to modify how the cluster runs your data flow job. And I mean that's quite advanced, and you might go through that later. In the interest of time, I mean, we create this pipeline object, which we saw about earlier. You read the file, right, from your input argument. You split the words, right, and you assign like the number one to every word, right, and then finally you kind of try to combine per word, and you kind of sum it out. So essentially, what you're doing is counting the number of uh, unique words within my file, right? So finally you will kind of format it, and you will write it to my destination, which is my output argument. And this is how the run function helps you to define the entry point to your code. And you can, I mean, there are complex pipelines which can branch out a lot, and you might need a more complex structure of a pipeline. This is a very simple pipeline that we are seeing here. If you go to examples here, you will see like a lot of examples that are already available. Like if you just want to run, I mean, this imports all the dependencies. This one kind of creates a p transform class. And now that I am creating the pipeline object, I want to read this particular text file, and then I want to count like per element, like how many words per word I have, right? So when I run this, it will process. Now you will ask me a question like where is this code running? It is running in a local runner. So we have multiple runners available, as I said. So we also have a local runner. So it is useful for development and lightweight computation purposes. This is running on a local runner for this particular notebook, and it will show you like the counts and all, like for every word, how many occurrences I have within my file. And I want to lower the case of my words, and I want to count like finally like how many are there. I mean, finally, if you just see here, you can also visualize the data, and this functions help you to visualize the data as well. So Vertex AI notebooks also help you to kind of visualize and develop your beam pipelines in a more friendly way, because it sometimes gets very inconvenient to code your data and pass it on to a data flow runner every time, right, or any other runner. So for development purposes, this is really good. And once the pipeline is ready, you can package it, and you can finally put it as a template and run it over data flow. So let's say we already have like a word account example which we went through, right? And we want to run this. What should we do? So you can directly call this particular Python CLI, and it helps you to launch a data flow pipeline by specifying the runner. So after I specify the runner, which is a data flow runner, automatically tries to create a data flow cluster within the project and the region which I specified. And of course, you should have all the permissions. And once that is resolved, it helps you to run the pipeline in Dataflow. And you can also run the templates as well, right? So once you try to run a template, we were talking about this one, right? The word count, it will have set of parameters. Let's say we try to calculate something. I have certain data here, I guess. So let's say I want to do for sample.txt, and I want to see for like where I want to write. I will write it to an output. Okay, select, and I want to define a temporary location which Dataflow can use while it's computing things. uh, it would be this particular folder, and I have certain restrictions, so I'll use private IP addresses and I'll run the job. That's it. And it also gives you the command line, equivalent command line, which is uh, useful sometimes where you want to automate within a CI/CD pipeline. Let's say what is the exact command which I want. So you get this ready, and once you see here, the job is currently initializing, and it tries to spawn all the worker nodes and the instances which are required to scale this pipeline. And finally, a job graph is also created, which will read the lines, count the words, map the elements, and write all the counts. And that's it. I mean, it will write data to the bucket which is specified. So if I go to that bucket and see the output of a previously run job, it's a similar job while I was testing things. Um, yeah, it's in the outputs. Yeah, here if you see, this is what we got, right? Like you'll see the counts for every word that we had within my input file. So that's it. I mean, this is all about data flow. I mean, this gives you like a very brief introduction to data flow, and I hope it enables you to kind of start using it and unleash its powers. There are a lot of things that you can find in the official cloud documentation, but if you want to explore more about data flow, there is a three-part course with quick labs. You can follow these links and access these courses, which help you to have some hands dirty on data flow. And there are a lot of things. I mean, this could have been a week training on data flow, but I tried to summarize and ensure I cover all the important elements of Beam and data flow, right? It was majorly Beam, but I hope it was helpful for you and get you to just get you started on this journey. Thank you for joining, everyone. I think we can take some questions. I have a hard stop in 2 minutes. Uh, if there are any more questions, I heard that this is going on YouTube. Please post comments. I'll be replying it personally.
Hello, Yash. There are questions in Q&A section.
Okay. Okay. I think one question is how Apache Beam is at runtime stream of data. How is it differs from Flink and Spark? Okay, I think the question is more around how data flow differs from Flink and Spark, because these are all runners, and Flink, Spark, and data flow as well. These are all runners, and how data flow differs is it gives you like, I mean, it kind of manages everything for you, right? It's a serverless service where you need not specify how many instances I want, what should be the configuration of my instances. You can do that by providing more advanced options, which are called pipeline options in Dataflow, and also the cluster options that you get while configuring your pipeline. But this is how it differs from Flink and Spark. I mean, in Spark, you will have, of course, have a cluster somewhere, and it's not scaling that well, right? Dataflow is fine tuned, and it is working specifically for Beam. To handle runtime data stream, which is best, Flink, Spark, or Beam? I would say, so see, in Spark, we have something called Spark streaming, and Beam as well. We have streaming in Beam. It totally depends on the use case, like where you want to use what. If your organization is more into Spark ecosystem and you don't want to have a learning curve, there are organizations which want to move towards more Spark oriented solutions. But I think Beam handles streaming data quite well. The transformations are quite well. Okay, one question is, where can I get the files from this class? Sasikala. So you can get, I mean, these are all open source files which you will get. So the presentation, like I unfortunately cannot share the presentation, but the files which I was talking, which I was showing, my apologies. I think I just saw the chat. I think things were not visible. I hope the YouTube, the YouTube video, if you see in HD, I think I'm sure you will be able to see the code which I was showing. But yeah, I mean, you will see, I mean, once you create like a vertex AI notebook, these examples come preloaded, or you can directly go to the GitHub page of Apache Beam. I mean, there are samples provided by Google, and which will help you to go through these examples and all the files which you're talking about. So I hope that helps. Another question
Thanks a
is,
lot, Yash. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful and hopeful. Hopefully, we can conduct more such sessions with you in the future. I hope everyone has filled up the feedback poll. If not, I request you to please do so, as your feedback is valuable and help us to conduct more such knowledgeable sessions. If you wish to conduct a webinar or are facing difficulty in registering, connecting with us at data@analyticsvidya.com. The recording of this session will be available within 2 days on our YouTube channel. Link is in the chat section. We will be back with another session of Data Hour tomorrow. The links of upcoming sessions are in the chat section. Till then, bye bye and keep learning.
all right, bye bye. Thank you for joining.